everyone, and welcome to our presentation on security of alerting authorities in the World Wide Web. This is joint work with Eric, Johan, Thomas, and Matthias, and I am Poyan Fotuiterani, a PhD student at Weizenbaum Institute in Berlin. So during crisis, emergencies, and disasters, people rely on trustworthy sources for information as well as for services. And one good source to get that information and services is via the web portals of a respective organization and entities. As you can see on the right-hand side, in February last year, as the corona pandemic was spreading throughout the US, only in 5 days, there were around 100 million visits were paid to CDC and NIH websites. So we can see that people are eager to get that information from authoritative sources. But at the same time, it has been a challenge for users to evaluate the trustworthiness of those sources. And actually, at these times, the number of scams and spams and whatever malicious activity that we see on the network goes up. So you would say, wait, we have some protection mechanisms for that, right? So I'm going to give you an example of how it went down here in Germany, where I live. You can see two websites. Both have sound domain names under .de, that's the country code top-level domain for Germany. Both have HTTPS enabled. A tech-savvy user could also verify that one of them has DNSSEC enabled, and the content looks identical. So there's no way that you could actually differentiate these two websites from each other. It's interesting to know that it was the malicious website that has like the heightened, higher security measures and had the DNSSEC enabled, and it was the website on the left side that managed to defraud 4,000 applicants of their paycheck protection plans. And the question is, if you take this example as the point of departure for research, the question is, what happens? What brings user to this point of falling victim to such scams? So we go way back to the point that an authority or an organization, whatever, wants to go online. The first thing that they do is they have a domain name delegated to them. So they have alternatives among the so-called generic top-level domains that are open to everyone, like .com, .org, that anyone can register. And there are also options, depending if you can fulfill the requirements, that are reserved for specific entities like .gov for governmental organizations. There's a difference for which domain name, there's a difference for users also, which top DLD you decide to choose for your organizations. If someone see that a domain name ends with a .gov, they would assume that you're an organization entity that has undergone some form of vetting and you have fulfilled some requirements. So it influences the quality of the trust relation that you would build up with that entity. The next step, which is technically speaking not required, is to get a certificate that can at least prove that you're the owner of the domain name. These are the so-called domain validation certificates. Or at best, it can prove your identity, the organization or extended validation domain names that some certification authority has went about and checked your credentials, have checked that your, I don't know, company exists, your address is correct, and you actually exist, and they vouch for the correctness of that information. In the last step, you put the certificate on your web server, you point your name servers to your web server, and on the other hand, the users would discover your domain name through email, newspaper, social media, whatnot, and would navigate over. So we have many components that all come together to realize this communication. And of course, each of them has an impact on the level of trust, if you will, or the security of this communication that is established at the end. We are going to focus on three aspects. One is on the top is regards the DNS and DNSSEC, the domain names as the starting point of any communication over the internet. Yes, you could use IP addresses, but no one does. So it would be de facto the starting point. It would give you an identity hint depending on which top-level domain you're using. As I said about like the .gov, which would imply that you're an governmental organization. We talk about the DNSSEC and how it secures the name resolution using cryptographic measures, how it protects the data origin authentication and data integrity. And finally, we studied the role of certificates. As I mentioned, depending on the certificate type, if it's an domain validation certificate, it's going to be used as proof of domain ownership. And if it's an organization validation or extended validation domain name, it's going to be used as a proof of identity. So if someone gets that certificate from your web server, they could verify who you are in the real world and not just on the internet. What we contribute in our work can be summarized in three steps. First of all, we define a threat model for web-based communication. We precisely define what we consider as secure. Terms like security and trustworthiness are maybe too vague, so we clearly define what we are looking for. Then we define a method to discover and analyze alerting authorities in the US. There is, interestingly enough, no central repository that you could ask, okay, give me the URL for, I don't know, a fire department in Orange County. And at the end, we put these two steps together and we investigate what we call the security profiles of alerting authorities in the US. So starting with our threat model, we define security on three dimensions. The first one is identification. You should be able to know with whom you're communicating so you can decide what type of trust relation you want to build with them. It's, of course, interesting in such critical situations, not necessarily for, I don't know, watching cat videos on the internet. The next dimension is resolution, that if you have found a domain name that you think is your target, your goal, it should be make sure that that domain name is securely resolved to the actual web server and not to some malicious one. And finally, if everything goes well, the transaction, the actual data exchange should be secured. The data should not be altered. It should not leak your privacy, and so on. So I explained components of web communication. Now we have the threat model. The question is, how can those components amount to realize a secure communication that matches our threat model? So let's see. I'm going to go through a couple of examples to show in an anecdotal way what we mean by security and our threat model. So it is all in the context of what we call assurance profiles. As an example, I took cdc.gov. The .gov domain name is a restricted TLD, so you would know governmental organization, check. They have DNSSEC enabled, resolution is secure, check. And they, at the end, if you establish a connection with the web server, they're going to provide you with an organization validation certificate, which would act as a proof of identity. So identification, resolution, transaction, check. We call this a strong assurance profile. The next one, Bernco, it's a county that has the similar profile as CDC, but it only provides a domain validation certificate, so it cannot be used for as a proof of identity. So you would know, okay, it's actually, okay, it's definitely a county, it's a governmental organization, but you wouldn't have any more information that you could uniquely identify who is behind that website. So identification is not that good. Resolution is okay because they have DNSSEC enabled, and transaction is also good because you can use the certificate over SSL TLS to exchange keys and secure the data exchange, the transaction. We call this kind of setting a weak assurance. Another example of weak assurance is the USPS.com. As you know, the Postal Service is also part of the critical infrastructure. If you think about the elections and the role that they are playing, it also becomes clear. Interestingly enough, USPS.com is under a non-restricted top-level domain name, so it means that anyone could try to spoof the name, because registering a domain name under .com is actually as easy as anything else. They don't have DNSSEC enabled, so they're open for not only resolution attacks, but attacks that also regard the domain validation certificates. I'm going to get back to that later. And at the end, if everything goes well, if the resolution is not compromised and you land at the authentic web server of the USPS, at least they provide an OV or EV certificate that can be as can act as an definitive proof of identity. So identification in this sense is incremental. If everything before that goes well, you can identify uniquely. The resolution is not secured because they don't have DNSSEC, and the transaction is okay. They have the certificate that can be used to exchange keys and secure the transaction. Moving on, this is the most insecure type of assurance profile that we are going to introduce. It's what we call an inadequate assurance. An example is giveforcdc.org. This is the fundraising website of CDC Foundation to raise money against COVID. And interestingly enough, they opt for .org, which is a non-restricted TLD. Very easy to spoof such domain names. At the time that I finished this slide, I checked that giveforcdc.net, for example, is open for delegation. They don't have DNSSEC. Well, you know the consequences. And at the end, they only provide a DV certificate. So as a user, if you go on the website and if you go through the checklist of all of these technical components that I mentioned, you wouldn't be able to know with whom you are communicating and if everything is actually has succeeded as you expected that. So for a website that raised more than tens of millions of dollars, it's really interesting that they have something, some assurance profile that we categorize as inadequate. So the details of how we put that together can be seen in this table. You have two columns: characteristics of DNS. Are you using your restricted TLD? Do you have DNSSEC enabled? Which kind of X509 certificate are you using? We don't get into the details of SSL. We don't check for cipher suits in this work. We only concentrate on the type of certificate. So you have two columns: domain validation or organization or extended validation certificates. And we sum up the implications of a specific combination, and we also assign an assurance profile to that. For example, the first row, if you have restricted TLD, if you have DNSSEC, if you have an OV or EV certificate, everything is good. You have no weaknesses. You have a strong assurance profile. The rest is you can see that what happens if some of these components of some of these characteristics are not optimal, and what kind of weakness is going to have that for you. So moving on, we're coming to the point that we actually measured real alerting authorities in the US to see how they are doing. To do that, as I mentioned earlier, there is no central repository that you can get a list of all organizations involved in emergency management and have like a domain name or a URL assigned to that. So what we did is we took the list of alerting authorities from FEMA. These are the list of all organizations that are connected to FEMA's alerting system. It's not exhaustive in the sense that it does not cover all the organizations involved in emergency management, but it's representative, you could argue. We went through, since the list only includes the name and the state or the territory, because the not incorporated territories are also listed. We go through Google, we give the list and the territory of operation and see if we can find a matching URL. We sanitize URLs. We also manually verify if our system works properly. It does. And then we do the domain namespace analysis. We check for DNSSEC. We see what kind of TLDs they use. We classify the type of organization that uses this domain name. And parallel to that, we check for active certificate that they're using. We also check for the historical certificates that have been in use under that domain name using the certificate transparency logs. We put all that together and we measure the assurance profiles for each of the organizations. We did that measurement from October 2019 to March 2020 from different vantage points in Europe and in the US. Many US organizations tend to block traffic from Europe. So it was good that we did that from both vantage points to account for that. We started with 1,388 alerting authorities from a list from September 2019 from FEMA. We mapped that to 1,365 URLs and 1,327 unique hosts, domain names, which you would know that some organizations are sharing the same domain name. So now we can get into the results. What have we found out? Starting with DNS and DNSSEC, we had three general questions in mind. Does each alerting authority have its own dedicated domain name? How do they integrate in the global DNS namespace? And do they actually use DNSSEC? So we found out that 50%, to be precise, 49% of alerting authorities do not have their dedicated names, which only means unnecessary dependencies. The X509 certificates are practically bound to domain names. So if you don't have your domain name, you cannot have an X509 certificates, and you're reliant on someone that has a certificate to host you on their domain name or whatever constellation that you're going for. So unnecessary dependencies if you don't have dedicated domain names. We see that more than 50%, more than half of the unique names are under non-restricted TLDs, which means poor recognizability and inferior security in the sense that for generic top-level domain names, it's very easy to spoof those names and to register names that may sound or look the same, but are not the same. And it was really interesting because for every type of organization that we investigated and that we have in our list, for public safety, governmental, law enforcement, military, educational, there is actually, at least in the US, there is actually a top-level domain name or a second-level domain name that is restricted and is reserved for these kind of organizations and entities. And it was interesting to see that people don't use that. Finally, it might not surprise everyone, but only about 4% have DNSSEC enabled. As you can see on the bottom right side, the .us locality namespace, for example, ca.us, which is for California. Some of those locality namespaces do not even have DNSSEC on the top level, so none of the domain names under them can use DNSSEC. We also saw that .gov domain names, which are mandated to use DNSSEC, don't use DNSSEC, which is very strange. But the results are comparing to the global trends. We see a heightened security, but it's only 4%, so it's not good. So moving on to the web PKI and analysis of web certificates, we did that on two levels. To what extent do alerting authorities adapt web PKI? These are the active certificates that they are using, and then look at the past, go through the time machine of certificate transparency and see what has been changed. Interestingly enough, we see that in 2019, about 15% provide non or invalid certificates. When I say invalid certificate, I mean the validation that is done by OpenSSL. OpenSSL is not as permissive as your browser. For example, if your web server does not provide the complete chain of trust, the chain of certificates that you need to verify, your web browser might be able to fill in the missing certificates and pass the validation. OpenSSL does not do that, so there's a difference. But at the same time, we also see hosts that they don't even have SSL or TLS activated, which means secure identification and transaction is simply impossible, because providing a certificate as a proof of identification happens through the context of SSL or TLS. And if you don't have that, no certificate, no identification. Then we moved through the time tunnel, and we have been asking ourselves which type of validation types for certificates have been popular. We see that OV and EV certificates, which play a major role in our third model, they're losing popularity. There are maybe some reasons for that. First of all, browsers don't care anymore about the different kinds of certificates. They're not doing a good job in differentiating that. They cost more. They are different certification authorities that provide domain validation certificates free of charge. So there are multiple reasons for that, but you can see on the bottom line that the OV certificates are just diving down in favor of DV certificates. We have been asking ourselves if the certificate usage has been exclusive. Interestingly enough, we see that certificate sharing is on the rise. What do I mean by certificate sharing? NX 509 certificate has a field called subject alternative name that you can list different domain names for which the certificate is valid. People use wildcards. You can have wildcards for extended validation certificates, but for the others, people use wildcards if they have different domains for the same organization. It's all okay, but what we mean by certificate sharing is that different entities actually use the same certificate, which leads to fate sharing. If one of those organizations gets compromised, every other one has to acquire a new certificate and also are at risk. There are different reasons for that. You can see on the graph on the bottom line that the number of unique subject alternative names has been rising. You see a lot of domain validation certificates from Let's Encrypt that have up to 100, which is the limit for the Let's Encrypt certificates. You see service providers that have multiple customers on the same infrastructure for which they're using the same certificates, which is very bad practice. And there might be also other reasons that we have missed. We also asked ourselves, what is the role of certification authorities in this whole ecosystem? And we see also that the CA giants like GoDaddy, that they provided like all-in-one packages, are losing their market share to automated DV certificate issuers like Let's Encrypt. As you can see in the graph below, Let's Encrypt, since their inceptions, they have been growing very fast. And it leads us to the conclusion that actually alerting authorities might care more about encryption, because with the domain validation certificate, you cannot do identification. and give less care to identification itself. So moving on, if you have the fine-grained details, now we're going to use our threat model to put all that together and see from the perspective of assurance profiles that I defined earlier in this talk. So what do we see if we put all these pieces together? We see that only about 22% exhibit strong or weak assurance profiles. Only 2% provide strong assurance profiles, which is not that good, specifically for governmental organizations that they should have the resources to have that kind of assurance profiles. Among those who have inadequate assurance profiles, which amounts to 67%, we see that mostly it's because of a combination of lack of DNSSEC combined with DV certificates. This is one thing that I wanted to mention earlier. If you don't have DNSSEC, there are specific types of attack that can cause certificate misissuance, specifically for domain validation certificates, because those certification authorities use automated procedures which heavily rely on proper resolution of DNS. And if your DNS is not properly secured, there's a chance they're doing their best not to allow such kind of attacks, but there's a chance that you can cause the certification authority to issue a certificate for a domain name that you do not own. So it's something that the DNSSEC also impacts the security of X509 certificates. Moving on, you can here in the highlighted part see the 15% that I mentioned earlier that provide that fail to provide valid certificates at all. So 78% total of inadequate weak assurance inadequate profiles is actually not a good number for critical infrastructure. So what can you do? If you recall the threat model that I mentioned before, the solution is not that complicated. You first need to choose securely delegated domain names, meaning that the domain name that you're using should be have DNSSEC enabled. Under restricted TLDs, depending on which field of operation you're involved in, and use OV or EV certificates. Best combination makes affiliations recognizable and proves identity. The next one is, okay, at least enable DNSSEC so that the name resolution is secure and you avoid possible misissuance of domain validation certificates. If you cannot use OV or EV certificates, at least you could use DANE EE certificates. Semantically, they are the same as DV certificates, but you have the sole control over that. So another certification authority cannot issue a certificate under your name because you have the control over your name servers. I know, similar to the case of browsers ignoring different kinds of certificates, browsers also ignore TLSA entries in DNS and also DANE EE, but here we only focus on the technical solutions that we have at hand, and we consider how we can combine that to enable secure communication. Moving on, use dedicated domain names and certificates. Makes sense. Avoids fate sharing. So if someone gets compromised, you're safe at least. If you're interested to see our data, our raw data, our statistics, our process data, you want to know more details, head to aa.segnow.net. You can see the list of all the alerting authorities that we investigated, and you can see their assurance profiles and the details of why we classified that as such. You can also find our tool chain, our data, everything else on Zenodo. It's also linked on the website. We contacted the alerting authorities. We informed them of our research and the assurance profiles that we assigned to them, positive or negative. if you have any questions, if you have any critique, or if you want to work with us, you can drop me a line at pfd@acm.org. And now I take any questions that you might have or any comments that you want to share with me. Thank you.
Boyan, thank you again for presenting and for joining us for this Q&A.
Thanks for having me.
You're welcome. The first question we have from our community is hasn't some of the groups like Let's Encrypt had their root certificates compromised or removed from trusted certificate authorities status by various groups?
Not that I know of. Our focus was on web-based communication, because I mean you can also have Let's Encrypt certificates for your mail server. I don't know for other fields of operation, but for web browsers, I haven't heard of any of the giants like Chrome, Firefox, or others to have that removed. But I can understand that if someone wants to have it removed.
Got it. Thank you again. This was enormous amount of work. This is very much an in-depth study, and at the very end, you kind of came up with a list of recommendations. And are there anything in addition you would like to share with our community based on all of this work?
I think one of the beside everything that I mentioned in this paper, one of the biggest challenges that we are going to have are the browser vendors themselves, because they have a very specific, some kind of hardwired idea of what is secure, and they try. I mean, they take over that decision from the users to themselves, and like Googles of this world always believe that trust us, we know what's good for you, and the rest is not your problem. Just one example. At some point, browsers removed the discrimination between different kinds of certificates. So if you look at your browser now, you only see the padlock. You don't see who issues that. You don't see if it's a domain validation or your extended or organization validation certificate, which was really helpful. They argued that users don't understand the difference. I argue that they did a bad job in educating users the difference between different certificates. So I think that is one point that needs more research and more work.
Okay, well, very good. And one last question is on, you mentioned that only 50% of the alerting authorities had a dedicated domain. Do you think it's just a matter of educating folks to and to make sure they understand that it is a best practice to have a dedicated domain? Is that where we stand at this point?
I think that would be that's a very good question, and it's really hard to answer. I think that is partly due to educating users on dedicated domain names, but I think partly, or even mainly, it's because that the resources are missing for critical infrastructure. It was really interesting to see, like, police departments, fire departments, everything that you really rely on during disasters, emergencies, and so on, they have really bad infrastructure. I had a couple of screenshots to show, but we don't have time for that. That you can see as if like it was the early 90s that they designed the website, and it's over there. So I think it's a question of also resources. That okay, if the state or county can host my stuff, then I'm okay with that. I don't need to take care of my domain name and my web server and so on and so forth. That would be my speculation.
I understand. Boyan, again, thanks so much for joining us.
Thanks for having me.
And for this Q&A.